Okay, in this question we've got a curve, we're given its equation, and we're given a point P, coordinates. Remember, whenever you're given coordinates, you're being given an X and a Y. Okay, we need to show that P lies on C, so we're going to end up by saying that. But to do that, we need to take P, so we're given an X and a Y, and here's our curve C, so we have to show the X and the Y values work in this equation. So if you take X to equal 3, plug it into all of this, get an answer, then you should get this answer here, and then you can comment that P does lie on C. Then we have to find an equation of a tangent. Well, a tangent is a straight line, so you're going to be using the y minus y1 recipe. But before you can use that recipe, you need a point and you need a gradient, so you need those two subheadings. So do we know a point here? Well, the tangent is at the point P, so the point P must be on the tangent, so we have a point. And the gradient, well, on this occasion, we have to select our method for gradient, but we haven't got 2 points, so it won't be the 2-point method. And it's not the gradient of a straight line at this point, it's a gradient of a curve, so we need to use dy by dx. So you differentiate to find dy by dx, and then you need an x value to put into your dy by dx, but we're dealing with the point P, so we do have an x value. So once you've got a gradient and a point, then you're ready to do the y minus y1 recipe, and it tells us that we want the answer in this form. Okay, and then we've got another point Q on C, and we've got the tangent at Q being parallel to the tangent at C. So we've got this word parallel. Now parallel means the two gradients have to be the same. So we already know all there is to know about the tangent to C at P. In particular, we worked out its gradient earlier, and parallel means the gradient at Q has to be the same as the gradient at P, and the gradient of the tangent is always given by dy by dx. So if you go back to your algebraic expression for dy by dx, then that's got to agree with the value you got before for the gradient. So your dy by dx expressed in terms of x's has to equal that number that you got for the gradient of the tangent at P. So this gives you an equation to solve. Okay, so you need to find values of x that solve that equation. Now, one of the values for x you're not going to be surprised by, because at P, which has this x coordinate, obviously the gradient will be that value, because the gradient of the tangent at P is what we're trying to equal. It will be the other solution for x that will give you the x coordinate of Q, and don't forget, for coordinates we need a y coordinate as well as an x. So the x coordinate you get by solving this equation, dy by dx, has to equal the other gradient that you had. The y coordinate, once you know x, of course, you've got a recipe here for y, so you'll be able to get the y coordinate. Okay, hope that helps.